Hello everyone, I welcome you to this tutorial. Our subject for today is Additional Mathematics for Senior High School 1, and your facilitator for today's lesson is Eric Uwenibon. You can call me Eric for short. Our topic for discussion today will be SURD, S-U-R-D, SURD. And for SURD, you must have your calculators closer to you, just like I have mine here, so you can see that, right? Good. Make sure you have your calculators closer to you because we are going to need it and we are going to use it. Good. And as said, at the end of this topic, this is what we expect to be able to exhibit. That is our learning outcome at the end of the topic. A is to perform basic operations on sets, and B is to be able to solve simple indicial and logarithmic equations. For our topic today, which is SURD, our first lesson, we are going to consider 1, the definition, the properties, and the simplifications of sets. 2, we are going to deal with rationalization of sets. That is the 2 things we are going to do in our first lesson under SURD. Good. And our learning indicator or objective for today's lesson is 1, investigate the properties of SURD and perform basic arithmetic operations on sets. 2, rationalize sets with binomial denominators. These are our 2 objectives that we are going to deal with for today's lesson. Good. Now, let's consider the expressions below. So, these are the expressions we have: the root of 4, the root of 9, the root of 16, the root of 25, the root of 36, the root of 49, the root of 81, the root of 100, and the root of 121. Very good. So I know by now your calculators are closer to you now. So let's pick our calculators as I'm bringing mine on the screen. Good. So this is what we have. Good. So let's punch these numbers on the calculator and write our results attached to the expressions that we have. So we are going to punch the root of 4, and that is giving us 2, right? Good. So let me pick my pen from my screen. So the root of 4 gave us 2. So this is our 2. Good. Now let's go and pick our calculator back again. Let's find the root of 9, giving us 3, right? Good. So root of 9 is giving us 3. Let's find the root of 16. Root of 16 and press equal to. That's giving us 4, right? Good. The root of 16 is giving us 4. Then let's look at the root of 25. The root of 25 is giving us what? 5. Excellent. So the root of 25 is giving us 5. Good. So I want you to punch the rest. The root of 36. What did you get? Did you get 6? Good. That is excellent. The root of 49. What will be your result? Did you get 7? Excellent. The root of 64. That is giving us 8. Good. The root of 81 will give us 9. The root of 100 give us 10. And the root of 121 give us 11. Very good. Very good. So now I want us to see another set of expression and use that to deduce our definition of a set. So now let's consider the expressions below: the root of 2, the root of 3, the root of 5, and the root of 6, etc., etc. These are just some few examples I just want us to use. Good. So let's recall our calculators back. So we are recalling our calculator. We have our calculator here. Let's punch the root of 2 and press equal to. See, the root of 2 is giving us root 2, right? Very good. Then let's change it and see. Then it is giving us 1.41421335662. Very good. This is giving us this value. For this expression over here, the decimal is a whole number and a decimal part. And the decimal part is 1 not recurring, and at the same time it is what? Not terminating. Here you can only see it terminated because the calculator cannot pick more than 10 decimal places. So that is why these decimal numbers have been truncated. So it goes to infinity. Good. So let's look at the root of 3. It still gave us root of 3, right? Good. When you convert it, will give you a whole number and a decimal fraction part, right? Good. The root of 5. The root of 5 will still give us root of 5, right? Good. The root of 6 still giving us root of 6. Good. So what can you say when you compare these expressions over here, the expressions we have below here, the root of 2, the root of 3, the root of 6, the root of 5, with the expressions we have on top here? We can see that the root of 4 is giving us 2, which is a whole number and a rational number. The root of 9 is giving us 3, which is a whole number and a rational number. The root of 16 is giving us same. The root of 25 is giving us same. The root of 36, and etc., etc. That means to tell us that whenever we have an expression, when we find the square root and it gives us a whole number value, then it means that those numbers are not described as what? Sets. But looking at the expressions below here, the root of 2 is still giving us root 2 on the calculator. When we simplify it further, it gave us a decimal fraction with a non-recurring and a non-terminating what? Values. That makes this expression an irrational number, and hence, for us to maintain its exact value, we must write it in that same form or structure. So for us not to lose the value of root 2, we have to write it back again as what? Root 2. For evidence sake, let's pick our calculators back again. I want you to try this and let's see if you are going to get the same thing. So if you have root 2 like this and we convert it to decimal, it is giving us 1.414213562. This is what I want us to do. Let's punch this decimal back on the calculator and press equal to and convert it and see if you are going to get a root 2. So we have 1.414213562. This was what we had when we punched root 2, right? Good. Let's press equal to. It is still giving us the same decimal fraction. Now let's try to convert it and see. You can see that when I press my SD, it cannot change. That means that the exact value of root 2 has been tampered with, right? Good. So for us not to lose the value of root 2, the calculator still leaves the answer of root 2 in the same form as what? Root 2. So this is to tell us that whenever we talk about a set, we can define a set as numbers that are written in square root form in order to maintain its exact what? Value. So we say sets are numbers with root that cannot be simplified to what? Whole numbers. And the root of 2 has given us a clear example. We can also define a set as numbers left in square root form to express their exact what? Values. Good. And one other way we can define a set, or we can term a set, is that sets are what? Radical expressions. So whenever you have an expression which cannot be simplified further in the form of a root sign, then we term it as what? Radical expressions. Good. So let's look at some examples of sets. Some examples of sets. So we can see. So we have the root of 2, we have the root of 3, we have the root of 5, the root of 6, the root of 7, the root of 8, the root of 10, and etc., etc. All these are examples of what? Sets, because they cannot be simplified further into whole numbers. And therefore, in order for us not to lose their exact values, we write them still in their same what? Structure as the root of that particular what? Number. Very good. Then, but expressions like the root of 4, the root of 9, the root of 16 cannot be said to be sets because their results are whole numbers, or can be expressed as what? Fractions. And we did that in root 4, we did that in root 16, we did that in root 25, and etc. for you to see that these numbers, when we punch them on the calculator, the answers we are getting are whole numbers, or they are rational numbers, or they can be expressed as a fraction in the form a over b. So we cannot term these expressions as what? Sets. Good. So example of these numbers is root 4 will give us 2. 2 is a whole number, 2 is a rational number, and 2 can be expressed as a fraction as what? 2 over 1. Good. When we have the root of 9, it is giving us 3. We have the root of 16, it is giving us 4. The root of 25 is giving us 5, and etc. and etc. And one thing you can associate with these numbers is that these numbers under the root sign that give us an answer in a whole number form or a rational value. These numbers are termed as what? Perfect square numbers. Why do we term them as perfect square numbers? Because these numbers are obtained as a result of the same number multiplying itself. An example is 49. We can see that 7 times 7, 7 multiplying itself 7, is giving us what? 49. An example is 64, which we have 8 times 8. It means that 8 is multiplying itself to give us what? 64. So 64 becomes what? A perfect square number. An example is 100, where we have 10 multiplying itself 10. Then 10 times 10 giving us what? 100. So 100 is also an example of what? A perfect square number. That means that when you find the root of any perfect square, then the answer you are going to get will be a rational number. Good. So let's continue. So we are now going to talk about types of sets. We have different types of sets that we are going to deal with. So our first one is a pure set. We say that a set having only a single irrational number is called what? A pure set. An example is the root of 2, the root of 7, the root of 3, the root of 13, the root of 5. Whenever you have a set having a single irrational number, we term it as what? A pure what? Set. right? Good. That means that a number cannot be expressed as a multiple of two numbers. So we term it as what? A pure set. Good. Our 2. We have something we call a mixed set. A set having a mix of a rational number and an irrational number is called a mixed what? Set. So whenever a set has a mixed set is a set which has a rational part and an irrational part. So we have an example here which is 3 root 2. So the rational part is the 3 and the irrational part is what? The root of what? 2. Another example is negative 4 root 5. The rational part is negative 4 and the irrational part is what? Negative what? 5. Very good. Then the next one is something we call a compound set. A set composed of two sets or a set and a rational number is called a compound set. An example is the root of 7 plus the root of 11. We say that a compound set can compose of two sets. So we have root 7 plus root 11. Root 7 is a set plus root 11 is also what? A set. So this is an example of what? A compound set. Or a compound set contains a rational number and an irrational number, right? Good. So the rational number part in the second example, we have 4 minus the root of 5. So 4 is the rational part. And the negative root of 5, that is the root of 5, becomes what? The irrational what? Part or the said part. Good. Then the next one, we have something called a binomial set. When two sets give rise to one single set, the resultant set is known as what? A binomial what? Set. So whenever two sets multiply or comes together to form a single set, we term it as what? A binomial set. So when we take the root of 6 for an example, the root of 6 is a binomial set because it is the root of 3 times the root of 2. That will produce the root of what? 6. The root of 14 is termed as a binomial set because it is the root of 2 times the root of 7. That will give us what? The root of 14. So the root of 14 is termed as what? A binomial what? Set. The root of 10 can also be said to be same. Why are we saying that? Let's use our calculator to verify. So you pick your calculators and let's punch the root of 2 times the root of 5 and press equal to see. It is giving you root 10, right? Very good. So root 10 is an example of what? A binomial set. Why are we saying that? Because it is the product of what? Two sets, which is root 2 times root what? 5. Very good. So let's move on to the properties of sets. The properties of sets. So our first property, 1, is when you have the root of A times the root of A, the result will give you the root of A all square. And when you find the root of A all square, the answer is going to give you what? A. That means that if you have two sets of the same kind or two sets that are alike and they multiply themselves, the answer is the value of the number under the root sign. Let's look at an example. That is, if we have the root of 2 times the root of 2, it implies that when we multiply these two sets together, we are going to get the root of 2 all square. And the root of 2 all square, the result is going to give us what? 2. to also include that if we have the root of 7 times the root of 7, or we multiply these two cells together because they are alike, we can write it as the root of 7 all square, which at the end of the day, this expression will give us what? 7. Let's pick our calculators and let's confirm these solutions. So you take your calculator and you punch the root of 2 times the root of 2 times the root of 2 and press equal to. So you can see you are getting 2, right? Very good. We do same with the root of 7. The root of 7 times the root of 7 and press equal to. That one too is giving us 7, right? Excellent. So that means that when you have two cells of the same kind and they multiply, the value of their product is just the number under the root sign. Is it okay? Good. So let's sample. We have the root of 11 times the root of 11. So you try this and you tell me the answer. That will give you the root of 11 all square, which is equal to 11, right? Good. Let's look at the second one, which is the root of 13 times the root of 13. Did you get the root of 13 square? And the results, final answer being equal to 13. Excellent. That is very good of you. Now let's move on to property number 2. We have the root of A times the root of B. The root of A times the root of B. When you have root A times root B like this, we can express it as the square root, that's a bigger square root like this. Then we multiply the two numbers under the square root together as A times B. So we multiply A and B and we put it under one square root like this. And A times B will give us the root of what? AB. So let's use an example to appreciate our expression over there. When I have the root of 2 times the root of 3, it is the same as 2 times 3, all under what? One root, just like I have shown here. And 2 times 3 will give us 6. So that will give us the root of what? 6. So that means that when you have two different kind of sets multiplying together, you just multiply the numbers under the root sign, then you give it what? A common root. That is why we have 2 times 3 as shown here, and with a common root like this. And 2 times 3 will give us 6, so that we will have what? Root 6 as shown here. Another example is when I have the root of 5 times the root of 7. Because they are two different kind of sets, you write a bigger root like this, as we have done there. Then 5 times 7 will be expressed in it as we have shown here. Then 5 times 7 will give us 35. Then we get the root of 35 as shown here. Good. So let's look at some trial question. A. Root 2 times root 11. Can you work it out? Yes. Give it a try. Now let's check our answer. It will give us root of 2 times 11, which will give us the root of 22. The next one, root 7 times root 3, which will give us 7 times 3, which is the root of 21. Excellent. Then the next one, which is root 13 times the root of 6. What will be the answer? That will give us the root of 13 times 6, and the result will give us what? The root of what? 78. Excellent. You have done a good job. Done a good job. So let's move on to the next property. That's property number 3, which is A times root B is the same as A root b. So when you have a rational number in the form of a multiplying a radical expression or a set in a form of root b, then this will be our final result or our final answer as what? A root b. So let's look at an example. When I have 3 times root 7, the answer will give us 3 root 7. When I have 11 times root 5, when I multiply, I will get 11 what? Root 5. Very good. So you try the examples below. We have 6 times root 7. What will be the result? So we have 6 root 7, right? Good. Now let's see this. We have the root of 2 times the root of 5. Over here, nothing changes. We have only interchanged the position of the root 2 and the rational number 5. So you use the same ideology that we used here. That's the rule, what it implies here. This is an irrational part. This is a rational part. So when you multiply these two expressions, I expect you to get the answer below, which is what? 5 root 2. Good. I know you had that. Congratulations. Let's move on to the next one, which is 8 root of 17. And our final answer there will give us 8 root 17. Good. That is good. Let's move on to the next property. That's property number 4. Our property number 4 says that if I have a root b, times c root d, if I have an expression of this kind, then the first expression here, which is a root b, it has a coefficient of a. The second expression here, which is c root d, it has a coefficient here, which is c. So we multiply the two coefficients together as a times c, as shown in the expression over here. Then we multiply the two expressions under the root sign also together, which is what? B times d, bd. Then we put them under one square root as shown here. Then a times c will give us ac, b times d will give us what? bd. Good. So let's look at an example. If we have 4 root 2 times 5 root 3, as I explained earlier, we multiply the two coefficients together. 4 times 5 will give us 4 times 5 in the bracket over here. Then we multiply the two expressions under the set together as 2 times 3. So we have the root of 2 times 3. So 4 times 5 will give us 20. Then 2 times 3 will give us 6, which will give us the root of what? 6. Then we are having 20 root 6 as our final answer. Then, if I have the root of 5 times 2 the root of 7, for these two expressions over here, this root 5 has a coefficient of 1, but it has not been written. So what we do is that when we are multiplying these two expressions, the coefficient in front of the root of 5, which is 1, will come and multiply the 2, as shown in the expression over here as 1 times 2. Then the 5 and the 7 will multiply under one common root, as shown like this. Then 1 times 2 will give us 2. Then 5 times 7 will give us 37. Then our final answer will be what? 2 root of 35. Sorry, it's 35, not 37. 2 root of what? 35. So that means that our 1 and 2 will multiply. Then our 5 and the 7 will multiply to give us 35 under the square root. So we have 2 root 35 as our final what? Answer. Good. So let's see a trial question. We are to multiply 7 root 2 by 3 root 11. So let's compare answers. Did we get 7 times 3 as shown here and 2 times 11 under the square root sign? So that 7 times 3 will give us 21. Then 2 times 11 will give us what? Root of what? 22. Good. Now let's look at the next one. We have 5 root 7 times 2 root 3. And that one will give us 10 root 21. That means our 5 times our 2 will give us 10. Then our 7 times our 3 will give us 21. Then the final answer will be what? 10 root 21. Then let's look at the last example, which is 4 root 13 times 3 root 6. So these two numbers will multiply as 4 times 3, which will give us 12. And 13 times 6 will give us what? 78. So our final answer will be what? 12 root of 76. That is very good. So let's move on to our next property. This time we have 8 root b times c root b. So you can see that we are having like set or set that looks alike. This is a root b, this is a root b. So we are going to apply the property number 1 that we did earlier, and I think property number 3, right? Good. So let's see. A times c will multiply to give us ac, and this is root of b, and this is root of b. So root of b times root of b will give us the root of b all squared. So that a times c will give us ac, and root of b all squared will give us b. So we have acb. Let's look at an example. We have 2 root 5 times 3 root 5, where 2 times 3 will multiply to give us 2 times 3 over here. Then the root of 5 and the root of 5 will give us the root of 5 all squared. So when we simplify further, 2 times 3 will give us 6, and the root of 5 all squared will give us 5. And we simplify further, as 5 times 6 will give us what? 30. So when you punch this expression on the calculator, we expect you to get this value. So let's pick our calculators and give it a try over here. So we have 2 root of 5 times 3 root of 5, and you press equal to. You see you are getting 30, right? Good. So this is how the calculator calculated it in the background to give us an answer of what? 30. That is what we have shown over there. So whenever you are given a question of this form, this is how we expect you to do what? To solve it. Good. Now let's continue. Another example. So we have the root of 7 times 11 root 7. Over here, just as I explained earlier, the root of 7 written over here has a coefficient of 1, but we don't write it. So when we are multiplying these two expressions, the 1 in front of this root 7 will multiply the 11 as 1 times 11. Then the root 7 times the root 7 will give us 7, right? Good. So 1 times 11 will give us 11. Then we multiply the 7 2 as 11 times 7. Then the final answer will give us what? 77. Good. So let's punch this one too on the calculator so that you get the root of 7 times 11 times 11 root 7, and you press equal to. That one is giving us 77, right? Good. So let's continue, this time with a trial example. The trial question. So we have 2 root 3 times 3 root 3. Work it out and let's compare answers. So when you multiply this, let's see the result you are going to get. We'll get 2 times 3 times 3, which will give us 18, right? Good. The next example, 2 root 2 times 7 root 2. Let's check our answer. That's 2 times 7 times 2 equals 28. Very good. So these are the answers you are going to get. Let's move on to the next property. That's property number 6. A root B times the root of C. Here, we are going to get the expressions here is A root B times the root of C. The coefficient of this root C is 1. And as usual, when you multiply that 1 by this A, you will get your A. That is why here we have A. Then this is a set, this is a set. When we are multiplying two sets, we multiply the numbers in under the square root. Since they are not alike, we multiply the numbers under the square root like this, and we put it under the same square root as the root of B times C. Sorry, the root of B times C. So that B times C will give us BC, and our final answer will be A root BC. Let's look at a trial example. We have 4 root 2 times 5 root 3. 4 root 2 times 5 root 3. So we are going to have 4 times 5 giving us 20. Then root 3 and root 2 give us 2 times 3 giving us what? The root of 6. So we have the expression over here. The next one is the root of 5 times 2 root 7. So here the coefficient here is 1. So 1 times 2 will give us 1 times 2 as shown here. Then 7 times 5 under the square root is also shown here. So that you get 2 root what? 35. Good. So try this example. A 7 root 2 times 3 root 11. Let's see what you get as an answer. 7 times 3, then 2 times 11 under the square root, which will give us 21 root of 22. Good. The next one, 5 root 7 times 2 root 3. And that one is giving us 10 root 21. Excellent. And the last one, which is 4 root 13 times 3 root 6. And that one also gives us 12 root 76. Excellent. Good. So let's move on to the next property. That's property number 7. This property says that if I have the root of A being divided by the root of B, I can write it as a single expression in the form I will divide A by B, then give it a common square root so that it will give us the square root of A on B. Let's use example to appreciate this property. So if I have the root of 2 divided by the root of 5, it is the same as writing the root of 2 on 5. That's 2 on 5 under a common root. Good. Our next example, the root of 9 divided by the root of 3. So you have 9 divided by 3 as a fraction. Then we will give it a common square root as shown over here. So if this can be simplified, 9 divided by 3 will give us what? 3. Then the final answer will give us that the root of what? 3. Good. I have the root of 14 divided by the root of 2. So we divide 14 by 2 as shown here. Then we will give it a common square root. So that 14 divided by 2 will give us 7. then that will give us the root of what? 7. Good. So trial example, we have the root of 22 over the root of 2 and the root of 7 over the root of 13. So you try your hands on this and let's continue. So for the first one over here, when you find this, you are going to get the root of 22 on 2, right? And 22 on 2 is going to give us 11. So the whole of this expression is going to give us the root of what? 11. When we come to this expression, you are going to get 7 divided by 13. Then you give it a common square root. Because it cannot be simplified further, we maintain it in that form. So let's talk about the rule number 8, which says that A times B root C, A times B root C. When you get an expression of this form, this expression over here, A will multiply the coefficient of the set. So we are going to have A times B. Then we will add our root C to the expression as A times B times root C. Then A times B will give us AB times the root C will give us AB root C. Let's look at an example. 7 times 5 root 3 will give us 7 times 5 as shown here. Then we maintain the root 3 as shown there, and that will give us 35 root 3. We have 3 root 5 times 2. Over here, the 2 will come and multiply the 3 as shown here as 3 times 2. Then you multiply it by this root 5 as 3 times 2 root of 5, and our answer is going to give us 6 root of what? 5. Good. Trial example. 7 times 3 root 11. Did you get 7 times 3 times root 11, which will give us 21 root 11. Good. The next one, 5 root 7 times 3. The answer is going to give us 15 root 7. The last question, which is 4 times 3 root 6. And the answer is going to give us 12 root 6. That is good. That is good. That is good. So let's talk about simplifications of sets. So when we talk about simplification, what do we want to imply? Let's see. We are saying that a set A root B is said to be in a simplified or basic form if B has no perfect square as a factor. A set A root B is said to be in simplified or basic form if B has no perfect square as a factor. That means that in simplifying set, we make sure that if the number under the root sign can be expressed as a multiple of two numbers with one being a perfect square, then it means that we must simplify that first to its basic form before we can say that this set cannot be simplified further. An example, when we have root 2, it cannot be simplified further, so it is in its simplified form. The root of 5 same, the root of 7, the root of 10, and etc. These numbers are already in their simplified form. Good. But expressions like root 12, root 18, root 50, and etc. are not in basic form, since perfect square numbers such as 4, 9, and 25 are factors of these numbers, 12, 18, and 50 respectively. So these expressions we have here, we cannot say that they are in their simplified form. Why? Because it can be expressed, the numbers under these root signs can be expressed as a multiple of two numbers with one being a perfect square. An example, If I have this 12, I can express it as what? 4 times 3. And the 4 is an example of a perfect square. This 18 will give us 9 times 2, and the 9 is an example of a perfect square. This 50 is a multiple of 25 times 2, and the 25 is a perfect square. So because we can find perfect squares as their factor, then it means we see that these expressions are not their simplified form. So let's see an example. Simplify the following sets. A, the root of 12. B, the root of 50. C, the root of 2 root of 63. C is 2 root of 63. So let's look at our solution. When I have the root of 12, I can express it as the root of 4 times 3. 4 times 3, right? Because 4 times 3 will give us 12. And I can split this expression over here as a multiple of 2 sets, which is the root of 4 times the root of 3. The root of 4 from our calculator, as we did earlier, the root of 4 give us 2, right? Good. The root of 4 give us 2 as shown over there. Good. Then the root of 3, since it cannot be simplified further, will be left in that form in order to maintain its exact value. So that 2 times root 3 will give us 2 root 3. So when you pick your calculator and you punch the value over there as the root of 12 and press equal to give you what? 2 root 3. The next one is root of 50, which will give us the root of 25 times 2. When we split it will give us root 25 times root 2, and root 25, since it is a perfect square, give us 5 times root 2, and the final answer will be what? 5 root 2. The third question is 2 root 63. Over here, to simplify this expression, we can split these two expressions into 2 parts as 2 times the root of 63. Good. Then we will break this 63 as a multiple of 2 numbers, with 1 being a perfect square, which will give us the root of 9 times 7. And since 9 is a perfect square, we can split it into 2 numbers, right? As 2 times the root of 9 times the root of 7. So the root of 9 will give us 3. Then we have 2 times 3 times the root of 7. And 2 times 3 will give us 6. Times the root 7 will give us 6 root 7. Good. Still under simplification of sets, express the following sets in its basic form. Good. So, when given a question of this form, let me use the calculator to show you how you can do it in a simple form without stressing yourself, right? Good. So let's have our solution over here. The first thing we have to do is that in your expression of this kind, we will have our root of 500 as we have this, and over here our root of 500 is given us as a multiple of 2 numbers, is given us the root of 100 times 5, right? Good. Then when we simplify this expression, or when we go further over here, we are going to split it into 2 as the root of 100 times the root of 5. And since 100 is a perfect square, when we simplify it further, we are going to get 10 times the root of 5. And at the end of the day, we are going to get 10 root 5 as our final answer. So whenever you are given the root of a huge figure or an expression like this, to simplify, especially if it is in the theory. This is what I would like you to do. Just draw your calculator, pick it up. I have this. Press your AC. Then you punch the expression as the root of 500 on your calculator. When you press equal to, it will give you 10 root 5 as it has been shown here. Good. But for you to get this first expression over here, whatever answer you had here, the one outside the square root, which is the 10, you square it or you multiply it by itself. So if I have this 10, I'll multiply this 10 by itself again, which is 10. So that it will give me 10 times 10. That will give me 100. Then I can now write it as what? 100 times 5 under the root sign. Then I'll simplify it further as we did that. Do you get it? Good. Let's look at the second expression. We have 6 root 75. We have 6 root 75. First of all, we will split 6 and root of 75 as 6 times root of 25 times 3. So if I'm to recall my calculator like this, we are only interested in the set part first, right? Good. So let's punch the root of 75 and press equal to. So it is giving you 5 root 3, right? Good. After that, whatever expression is outside the root sign, which is 5, multiplied by itself. So this 5 times 5 will give us what? 25. So it means that under the square root, we are going to write what? 25 times 3, as shown here. Then, we break this set into 2 as 6 times the root of 25 times the root of 3. Then the root of 25 being a perfect square will give us 5, which is 6 times 5 times root of 3. Then 6 times 5 will give us 30 times the root of 3 will give us 30 root 3. Good. So let's look at the last one. We have the root of 175. You are being given this to simplify. So this is how you go by it again. Over here, you write 175 as this. You write it as a multiple of two numbers, with 1 being a perfect square. And for your work to be easier, just punch this expression on the calculator as shown on your screens. So you have the root of 175. Then you press equal to. It will give you 5 root 7, right? Good. Now the 5 outside the square root multiplied by itself as 5 times 5, which will give you 25. Then we are now going to write 25 times the 7 inside the square root, all root as shown over here, 25 times 7, all root. You do this, then later we split it into 2 as the root of 25 times the root of 7. Then the root of 25 will give us 5, the root of 7 will give us root 7. Still maintain the exact value for us to maintain the exact expression. Then 5 times root 7 will give us 5 root 7. Good. So these are some trial examples. I want you to try on your own. So simplify the following expression. A, the root of 27. B, 3 root 128. C, the root of 605. So our answers are below. The first one will give you 3 root 3, right? Good. The second one will give us 24 root 2. And the last one will give us 11 root 5. So let's move on to addition and subtraction of sets. Addition and subtraction of sets. one can only add or subtract sets that are of the same form. Two or more sets are alike if they have the same number under the root sign. Example, root 2, 3 root 2. These two sets are said to be what? Like set, because the numbers under the root sign are the same. While 3 root 2 and 2 root 3 are unlike sets. Why? Because the numbers under their square root are not the same, and therefore they do not look alike. And when they are not alike, we can neither add nor what? Subtract. Good. So let's talk about addition of sets. It says that if I have m root a as my set plus another set as n root a, then when we add these two expressions, we will add their coefficient as m plus n as shown over here. Then we will bring one of the square root to come and multiply that expression as m plus n root of what? A. Example, simplify the root of 12 plus the root of 5. So in our solution, over here, this root of 12, you take your calculator, punch the root of 12, the root of 12, the root of 12, sorry, the root of 12, which is giving us what? 2 root 3. That means if you are going to express this root 12 to give us, you multiply this 2 by itself to give us what? 4. So that one will give us 4 times 3 under the square root, right? Good. Then we do same for 75 as the root of 75. The root of 75. That one to give us 5 root 3. So you multiply this 5 by itself again to get 25. So I get 25 times 3 under the square root as shown over here. So this will give us 4 root 3, a root of 3, sorry, root of 4 times root of 3 plus root of 25 times root of 3. Good. Then this root of 4 will give us 2, so that 2 times this will give us 2 root 3. This root of 25 will give us 5. 5 times root 3 will give us 5 root 3. Then we add their coefficient as 2 plus 5 as shown here. Then we add the root 3 to multiply the expression. So over here we will get what? 7 root 3. Still under addition of sets, addition and subtraction of sets, still under addition. Add the following expressions, leaving your answer in set 4. So we have a root of 24 plus root of 96. We have question number 2, which is root of 32 plus root of 128 plus root of 50. 3, we have 3 root 8 plus 3 root 200 plus 2 over 3 root 162. Then we have the root of 80 plus the root of 28 plus the root of 20 plus the root of 63. So our solution, I'm only going to deal with the first 2 examples, then you deal with the rest later, right? Good. So let's look at the first expression. If I have the root of 24 plus the root of 96, I must express each one of these in their simplest form before I can add. So I'll pick my calculator, then I'll punch the root of 24. The root of 24 So that will give us 2 root 6. That means you multiply this 2 by itself to get what? 4. Then that expression is going to give us 4 root 6. And our that expression is going to give us 4 times 6 all under a root sign. Then let's look at the 75 before I go and write. So 75 or 96 will give us 4 root what? 6. So that means this 4 multiply itself to give us 16. So we are going to get 16 times 6 all root. So let's see what we have here. So for this expression, we have 4 times 6 all under one root sign, and 16 times 6 all under one root sign. Then the next one, we split each one of them to give us 4 root 6 times root of 6. To give us root of 4 times root of 6, then plus the root of 16 times the root of 6. The root of 4 will give us 2, so 2 times root of 6 will give us 2 root 6. The root of 16 will give us 4 times root of 6 will give us 4 root 6. Then, now that the sets are the same, we can add their coefficients as 2 plus 4. Then we add the root 6 attached to it, so that 2 plus 4 will give us 6 root 6. You can confirm with your calculator to see if your answer is right. So we have the root of 24, plus the root of 96. So we are getting 6 root 6, right? Good. Let's move on to the second one, which is the root of 32 plus the root of 128 plus the root of 50. Here there is nothing new. We have only made it 3 expressions just to confuse you a little. Just follow the same approach and you will get it right. So over here, the root of 32, the root of 128, the root of 50 for 32 will give us 16 times 2. But 16 times 2 will give us what? 32. And this 16 we know is a perfect square, right? Good. The root of 128 will give us 64 times 2, all under a root sign. Then the root of 50 will give us 25 times 2, all under the root sign. Then the next part is to split each one of them. So for the first expression here, we are going to get the root of 16 times the root of 2 plus this expression here will give us the root of 64 times the root of 2. This expression over here will give us the root of 25 times the root of 2. The root of 16 will give us 4 times root 2, give us 4 root 2. The root of 64 will give us 8 times this, will give us 8 root 2. And the root of 25 will give us 5 times that, will give us 5 root 2, as shown over here. Then we add their coefficient as 4 plus 8 plus 5. Then we add one of the root 2 to multiply the expression like this. This and that will give us 12. Then we add the 5, and the result is going to give us 17 root of what? 2. After which, you can punch it on your calculator to confirm your answer. So we have the root of 32 plus the root of 128 plus the root of 50. That's 17 root 2. Good. So for example 3, example 4, you have to try that on your own. Right? Good. Addition and subtraction of sets. Good. So we are now heading on to the subtraction aspect of it. Then under the subtraction, it says that if we have m root a minus n root a is equal to m minus n in brackets times the root of a. So we subtract or find the difference between the coefficients. Then we pick one of the set to multiply whatever expression we have. Do you get it now? Good. Let's look at an example. Simplify root 162 minus root 18. When we have this expression, this is how to go by it. Now solution, we have our expression here as the question stated earlier. Then we bring our calculator. So let's bring our calculator on board. This is our calculator. Then we punch the root of 162. 162. You press your equal to. That will give you 9 root 2, right? Good. Then this time you multiply the 9 by itself again. So 9 by 9, we get 81. Then we now write it the root of 81 times 2 under a square root, right? Good. You do same for the 18. When we pick the root of 18, that one is giving us 3 root 2. So you multiply this 3 by itself, which is 3 times 3, giving us what? 9. So under the root sign, we are going to have 9 times 2, all under what? The root sign, just like we have here. So let's see. Good. So we have root of 81 times 2 for the 162. Then we have our minus here. Then the root of 9 times 2 for the 18. Good. Now we split the 81 times 2 all root into 2 parts, so that we will get the root of 81 times the root of 2 minus the root of 9 times the root of 2. Then we simplify the 81. The root of 81 will give us 9, and that 9 will multiply this root 2 to give us what? 9 root 2. To give us 9 root 2 as shown here. Then root of 9 will give us 3. 3 times root 2 will give us 3 root 2 as shown over here. Then since the two sets are alike, we consider the coefficient by finding the difference in the coefficient, which is going to give us 9 minus 3 in one bracket times the root of 2, which is what they said. So 9 minus 3, when we simplify, that one will give us 6 root 2. And that means when we pick our calculator back again here, and we punch the expression, the root of 162 minus the root of 18. And you press your equal to sign, it will give you what? 6 root 2. Good. So let's continue. So let's look at an example. Simplify 1, the root of 80 minus the root of 45, 2, the root of 24 minus 3 root 6 minus 2 root of 206. Then we have the root of 112 minus the root of 2 minus the root of 63. And we have the root of 2 plus the root of 50 minus the root of 18 minus the root of what? 18. So let's look at solution. I'll deal with the question 1 and 2, then you will deal with what? The question 3 and the question number 4. Good. So the first one, we are having the root of 80 minus the root of 45 as shown in the expressions here. So we will have this, the root of 80 minus the root of 45. So as usual, when we pick our calculators, I know you have yours, and you punch the root of 80. Let's see what we are going to get. That one is giving us 4 root 5, right? Good. Then you multiply this 4 by itself again to get what? 16. Then under the root sign, you write it as what? 16 times 5, or root. Good. After that, you do same to the 45. So you have the root of 45. You press equal to give you 3 root 5. So multiply this 3 by itself to get 9. Then under the root sign, we are going to write it as 9 times 5, all under this what? Square root. Good. Then, since we are able to do it in this form, we split them into sections or into 2 parts. Just as we are going to have this, we are going to have the root of 16 times the root of 5 minus the root of 9 times the root of 5. Good. This root of 16 is a perfect square. The number 16 is a perfect square. So when you find its root, it will give us 4. Then that 4 times 5 will give us 4 root 5. Our 9 over here too is a perfect square. When you find the root of this 9, you get 3. 3 times 5 will give you 3 root 5. Sorry, so it's 3 times root 5. So the root of 9 will give us 3 times root 5 will give us 3 root 5. So we have 4 root 5 minus 3 root 5. The root 5 are alike. So it means that these sets are like what? Sets. So it means we can find a difference in the coefficients. So we have 4 minus 3 or root 5. The 4 minus 3 is in one bracket, then we multiply by the root 5. Then 4 minus 3 will give us 1 times this root 5 will give us 1 root 5. And you know in mathematics, whenever the coefficient is 1, we normally write the expression itself without bringing the 1. So over here, we are going to get what? Root 5 as our final what? Answer. So you pick your calculators. So I've picked mine here on the screen. Then let's punch the expression as the root of 80 minus the root of 45. And you press your equal to, and that will give us what? The root of what? 5. Good. So let's continue. We look at question number 2. We have root of 24 minus 3 root 6 minus root of 216. Over here, we will find the simplified versions of each one of these. But first, we must use our calculator to determine how the expansion of each is going to what? Be. So we bring our calculators and let's see. I want us to do that. After that, I'll come and write it. So we have the root of 24 and that is giving us 2 root 6. So 2 root 6 means that if you multiply the 2 outside the root sign by another 2 again, we are going to get 4. So it means that under our root sign, we are going to get the root of, so it means we are going to get the root of, should be something like this, the root of 4 times 6 for the 24, right? Good. Then, when we come to the next one, which is 3 root 6 is already in its simplified form. It cannot be simplified any further. So over here, we maintain it as it is by not touching it. Then we come to the next one, which is the root of 216. So we punch the root of 216. You press your equal to sign to give you 6 root 6. That means if you multiply the 6 outside by another 6 again, then it is going to give us 36. So which implies that we are going to have an expression in this form as 36 times 6 under the root sign 4216. So let's see how it is going to be. So for the 24, we are having 4 times 6 under the root sign, because 4, 6 will give us 24, and 4 is the perfect what? Square. For the 3 root 6, it is already in its simplified form, so you don't touch it. Then we come to the 216. That's the root of the 216. Then that one will give us 36 times 6. So over here we split them. We get root of 4 times root of 6 minus 3 root 6 minus root 36 times the root of 6. Then the root of 4 will give us 2. You multiply it by this root 6, then it will give you 2 root 6. For minus 3 root 6, we still maintain it as minus 3 root 6. And the root of 36 over here will give us 6 times root 6 will give us 6 root 6. But don't forget that over here we have a negative sign. So that will give us negative 6 root 6. Now that we have this, then we can see that all the three expressions here have root 6 in them, and as a result, they are all like terms, right? Good. So we now consider adding or subtracting the coefficients. So over here, we are going to get 2, which is the first coefficient of the expression here, 2, minus the coefficient of the second expression, which is 3, minus the coefficient of the third expression, which is 6. We put them all in one bracket. Then we multiply it by the said. That is the like said, which is root of 6. So over here, you have 2 minus 3 minus 6. So that will give us negative 7 root of what? 6. Good. So example 3 and example 4. You have to try it on your own and compare your answers with your colleagues. Even after trying it, you can decide to punch it on the calculator to test your answer to see if you had the right what? Answer. Good. So let's continue. Let's look at some trial questions. Simplify the following. A, we have root of 128 minus root of 50 plus 2 on 3 root 162. B, we have 2 root 175 minus root of 567. C, we have root of 200 minus root of 50 plus root of 8. So these are the three examples we want you to try on your own. So let's look at conjugates of sets. Good. I know you have seen a mirror before, right? Very good. So when you stand before a mirror, what can you say about the characteristics of the image that is being formed on a mirror? So you can see that when you stand in front of a mirror, you see your own image there, right? Then, whatever action you make, especially with your arms, you can see the image is doing the opposite of it. That is, if you raise your right arm, then the image on the mirror raises its left hand. When you raise your left hand, then the image raises the right hand. That is how, or that is the concept of what conjugates in the world of what sets. Good. So let's see. We say conjugates are like mirrors in the world of what sets. They are formed by simply changing the signs of the radical part in the said expression. That is, if positive, change it to negative, and if it's negative, change it to what? Positive. When a said is multiplied by its conjugate, the result is a rational number due to the difference of two square property. Let's consider the expression below. Good. So we have a said and it what? Conjugate. So when I have the root of A as a said, its conjugate is the same as what? Root A. When I have A root B as a said, like this, its conjugate is what? Root of what? B. So over here, we only consider what? The said part, not the coefficients. When we have A minus B root C, its conjugate is the same expression over here, but this time, the negative sign over here changes to what? Positive. That is why we have A plus B root C. So the same expression, but negative becomes positive. When I have A plus B root C as my said, then its conjugate will be A minus B root C. If we have A plus root B, its conjugate will be A minus root B, the same expression, but positive changes to negative. And if I have A minus root B, its conjugate is what? A plus root B. So if I have root A plus root B, its conjugate should be root A minus root what? B. And if I have root of A minus root of B, its conjugate should be what? Root of A plus root of what? B. Good. So these are sets and their conjugates. So simplify the following expression by multiplying each one by its conjugate. So we have this expression, and the question is saying we should multiply each one of them what? By its conjugate. So you have your solution. Then we have our first expression, which is for set question A. We have our set to be root 5. Then the conjugate of root 5 is still root 5. So if I'm going to multiply the set by its conjugate, then it is going to give me root 5 times root 5. And the result is going to give us what? 5. Good. When we look at the second expression, which is 3 plus 2 root 3, that becomes the set that was given. Then its conjugate is the same expression, but this time positive changes to what? Negative. Good. Then we're multiplying the set by its conjugate. Then we are going to get an expression like this. Bracket open, 3 plus 2 root 3. Bracket close, another bracket open, 3 minus 2 root 3. Good. Then in our algebraic expression that we have been doing from basic school till date, we will pick the first expression over here, which is 3, multiplied by the last bracket over here, which is 3 minus 2 root 3. That is what I have done here. Then we will pick the plus 2 root 3 as our plus 2 root 3. Then it will multiply the second bracket over here, which is 3 minus 2 root 3. That is what we have done here. After that, we expand each of the brackets what? Separately. So we are going to have 3 times 3 here, giving us 9. 3 times minus 2 root 3 will give us negative 6 root 3. 2 root 3 times 3 will give us positive 6 root 3. Then 2 root 3 times negative 2 root 3. The 2 and the 2 will multiply to give you 4. And this is root 3 times root 3 will give you what? 3. But don't forget that this is negative, so positive times negative will give you what? Negative. Good. Then in this expression, you can see that we have negative 6 root 3 and we have positive 6 root 3. So what it means is that over here, this positive over here is going to cancel the negative over here. And when that happens, when that happens, it means we are going to get 9, and this is minus 4 times 3 will give us minus 12, because this and that will cancel out. Good. Then 9 minus 12 will give us negative 3 as our final what? Answer. Good. Let's look at example number C. we have root of 5 minus 2 root of 3. Its conjugate is the same expression, but the negative will change to what? Positive, as root of 5 plus 2 root 3. Then we multiply the two expressions as we did in the first or second example over here. We do the same expression over here, this times that. But over here, there is a difference of 2 squares just like we have this. So you can decide not to expand it as we did it in that form. So over here, because the expression here and the expressions here are the same, but the difference is here is positive and there is negative, it makes this expression what? A difference of 2 squares. So what you do is that we will consider the one with negative in between the two expressions. Then we put the first expression into one bracket and square it. So you have the root of 5 all square. Then we pick the second expression after the negative sign, which is 2 root of 3 in another bracket, then we square it. So the root of 5 all square will give us 5, and the 2 root 3 all square, just pick your calculator, just as we have this is our calculator. So we are going to have 2 root of 3 all square. Then you punch it on the calculator. The answer is going to give you what? 12. Excellent. So it means that one is going to give us 12, and which implies that this 2 root 3 will give us 2 square will give us 4, and root 3 square will give us 3. So we are going to get 5 minus 12, and the final result is going to give us negative what? 7. Good. So example number D, which is 3 plus 2, example D, which is 3 root 2 plus root 3, you have to solve it on your own and compare answers with your colleagues. So let's talk about rationalization of sets. Rationalization of sets. When we talk about rationalize, it implies to take away a root sign or a set from the denominator of a particular what? Fraction. So, in actual sense, in mathematics, we don't leave our answer in a form of a fraction whereby the denominator is a set or the denominator is an expression with a root sign. So when that happens, you have to make sure you take the denominator, which is the root sign, out of the denominator and bring it to the numerator. So the process of doing that is what we term as what? Rationalization. Good. So we say rationalization, it refers to removing the set or radical expression at the denominator of a fraction. This is done by multiplying the given expression by the fraction of the conjugate sets. So before you can rationalize, you must know the conjugate of that set at the denominator. Then you multiply the expression that you have by the conjugate of that fractional set. Good. Let's see an example. Simplify the given set. Simplify the given set. Simplify the given set. We have A, 2 over root of 3. We have B, 5 over 2 root of 7. And we have C, root of 3 divided by root 5 plus root 2. Good. So when we have this expression, this is how we go by it. Let's try to solve it together. So in our solution, our A, we have 2 over root 3. our A, we have 2 over root 3. And looking at the denominator here, the said there is root 3. And the conjugate of root 3 is root 3. So it means that we multiply this fraction over here by the fractional conjugate of the denominator. So since the conjugate is root 3, we multiply the expression by root 3 over root 3. So that 2 times root 3 will give us 2 root 3. Then root 3 times root 3 will be given as shown over here as root 3 times root 3. Then the numerator will still remain as 2 times root 3 or 2 root 3. Then root 3 times root 3 will give us what? 3. Good. So when you pick your calculator and you punch this expression over there as 2 over the root of 3, and you press your equal to sign, you can see you're also getting 2 root 3 on 3, right? Good. So that is how the calculator calculated it at the background and gave us a result as we have shown on our screen. Good. Let's continue with example number 2. We have 5 over 2 root 7. So over here, the denominator is 2 root 7. And we say that whenever you have a set in this form and you want to rationalize, you want to find its conjugate, we only consider the set part and not the rational part. So over here, we consider the root 7 as its conjugate. So we multiply the whole of this expression by root 7 or divided by what? Root 7. Then 5 times root 7 will give us 5 root 7. Then 2 root 7 times root 7 will give us 2 root 7 times root 7 as shown over here. Then the numerator will still remain as it is as 5 root 7. Over here we have root 7 times root 7 will give us 7. But don't forget we already have a coefficient of 2 for the first expression. So we are going to have 2 times 7. So the numerator will still remain constant as 5 root 7. Then the denominator 2 times 7 will give us 14. And our final answer will be what? 5 root 7 all divided by 14. So punching this on the calculator, we are going to have 5 divided by 2 root 7, and you press your equal to sign, and you see you are getting 5 root 7 divided by what? 14, as we had it on our screens over here. Good. Let's look at the third example. We have root of 3 divided by root of 5 plus root of 2. So over here in this expression, the denominator over here is a compound what? Set. So you can see that over here, our set over here, the denominator over here, the operation between the two sets over there is addition. So its conjugate will be the same expression, but it will be in a negative what? Form. So that means we multiply this whole fraction over here by the conjugate of the denominator in a fractional form. So root of 3 divided by root of 5 plus root of 2 times root 5 minus root 2 divided by root 5 minus root 2. So you can see that the denominator over here, this is the conjugate of that. Have you seen that? Good. Then we multiply the two numerators and we multiply the two denominators. So root of 3 is multiplying every expression over here. So since this is a single expression and this is a double expression or expression in 2 terms, then it means I'll put the one in 2 terms in brackets. Then I'll have my root of 3, bracket open, root 5, minus the root of 2, bracket close. Everything divided by the multiplication of this set by its conjugate as shown on the screens. The next part is to expand the numerator. So root 3 times root 5. When I punch it on my calculator or on your calculator, you are going to get the root of what? 15. So let's see. Let me draw my calculator here. If I'm to bring it here. Good. So you are going to have the root of 3 times the root of 5, and that is going to give us the root of 15 as shown here, right? Good. At the same time, we are going to have the root of 3 times the root of 2, root of 3 times the root of 2 here, and that is going to give us the root of what? 6. Good. So that is why over here at the numerator, root this times root 5 will give us root of 15. Then root 3 times root 2 will give us the root of 6 with this negative in between them. Because these two sets are unlike sets, we can neither add them nor subtract. So we still maintain it in that expression as shown above. Good. Now the denominator is a difference of two squares. That is a set of the same kind, right? But over here is negative and over there is what? Positive. So when that happens, because it's a difference of two squares, we only concentrate on the one with the negative expression, then we square the numbers before the negative sign and after the negative sign. So you can see that I have the root of 5 all square minus the root of 2 all square as shown on your screen over here. Good. Then the next part is we still maintain root 15 minus root 6 on top of our numerator fraction. Then the root of 5 all square will give us 5, and the root of 2 all square will give us 2 with our negative sign in between the two expressions. So 5 minus 2 is going to give us 3. Then we have the root of 15 minus the root of 6 all on what? 3. So you can leave your answer like this, or you split them into two expressions. That will give us the root of 15 divided by 3 minus the root of 6 divided by 3. And this will be the final answer. So if you leave your answer like this, you are not wrong. If you leave it like that too, you are not wrong. But it will be dependent on how the question wants you to leave your answer. So let's take our calculator. So we are going to have the root of 3 divided by the root of 5 plus the root of 2. Good. When you press equal to, then you get the answer as shown on your screens over here. This is what you had on the calculator, right? Good. Good. So that is it when you talk about what? Rationalization of sets. Simplify the following. This is a trial example. So you try it on your own, then compare your answers with your colleagues. You can also punch it on the calculator to get your answer. But please do solve it. After that, verify with your calculator. So we have 1 over root 11. We have 7 over 3 root 2. And we have root 5 all over root of 7 minus the root of what? 5. We have an assignment. Simplify the following. This is a DOK level 1 question. So we have question 1, 3 root 12 plus 2 root 300, 9 root 8 plus root of 72 minus 9 root 8, which is question number 2. We have root of 27 plus 2 root of 5 plus root of 20 minus 2 root 3, and we have root of 18 times root of what? 20. Then our next question, set of questions, a DOK level 2 question, which is write the conjugate of the following sets. So we have root 2 plus 3 root 5. We have 2 root 7 plus 5 root 3. We have 5 root 2. Then B, simplify the following by multiplying by its conjugate. So we have root of 6 plus 3 root 2. We have 2 root 7 plus 3 root 5. Then we have root 2 minus root 5. Good. Then DOK level 3 and 4 questions. We have rationalize the following sets. So we have 4 over 7 root 3. We have root 3 over root 5 plus 2. Then we have root 3 plus root 2, all divided by root 2 minus 3 root 3. Good. End of the first lesson. Bye-bye. Hoping to meet you for the second lesson. Thank you.